Assalamu alaikum. Myself, Dr. Ansari Farzana Veduzama, Department of Chemistry, J.A.T. Arts, Science and Commerce College, Malegaon. Welcome all of you. In the previous presentation, we have seen about the colorimetry and different terminologies which are used during the course of colorimetry analysis are radiant energy, radiant power, absorbance, transmittance, absorptivity, path length, and the molar absorptivity. And also we have seen the fundamental law of photometry. That means when we allow a radiation to fall on the medium, some part of the radiant energy gets reflected, some is refracted, some absorbed, and remaining is transmitted. So this equation can be written as P0 is equal to PR plus PA plus P, where P0 is nothing but radiant power of incident light, PR is the radiant power of refracted light, and PA is the radiant power of absorbed light, and P is the radiant power of transmitted light. If a comparison cell or the same cell is used during analysis, the value of which is very small, nearly equal to 4%, and can be eliminated for air glass interface. Under this condition, this equation becomes P0 is equal to PA plus P. That means radiant power of incident light is the sum of radiant power of absorbed light and radiant power of transmitted light. Two fundamental laws underlie the practice of photometry are Lambert's law and Beer's law. Lambert's law states the relationship between the radiant power of absorbed light with thickness of the medium, whereas Beer's law states the relationship between the radiant power of absorbed light with the concentration of the medium. The combined law form of this law is called as Lambert-Beer's law. We shall discuss one by one. Lambert's law. When a beam of monochromatic light is allowed to pass through a transparent medium, the rate of decrease of radiant power with thickness of medium is directly proportional to the radiant power of incident light. Mathematically, Lambert's law may be stated as minus dP upon dB is directly proportional to P. In order to eliminate proportionality constant, it becomes minus dP upon dB is equal to K1P, where dP is the change in radiant power when the light of radiant power of P passes through infinitesimally small thickness of the sample dB, and K is called proportionality constant, and minus sign indicate that radiant power decreases as light path increases. You will be better understood with the help of this example. That means it is the thickness of medium. When the incident radiation is allowed to pass through this medium, if thickness is small, the absorbance is more. And when thickness is small, absorbance is small. As thickness increases, absorbance goes on increasing, because when thickness is increases in the path of the radiant power of incident light, there is much more absorbing species are present. Therefore, absorbance is more. See here, the previous equation becomes minus dP upon P is equal to K1 into dB. Now, integrating the equation between the proper limit, suppose that we integrate dP upon P between the limit P0 to P and the equation K1 dB is integrated between the limit K1 0 to B K1 dB. On integration, it comes out to be minus ln P upon P0 is equal to K1 into B, or this equation, in order to eliminate minus sign, it can be inverted. So therefore it becomes ln P0 upon P is equal to K1 into B. In order to change ln log to the base e into base 10, it is multiplied by 2.303. Therefore, this equation becomes 2.303 log to the base 10 P0 upon P is equal to K1B. On slightly rearranging this equation, take this 2.303 from this side to this side. So this equation becomes log to the base 10 P0 upon P is equal to K1 2.303B. But log of P0 upon P, we have seen that it is equal to absorbance. Therefore, instead of writing this, you can write absorbance. Okay. And K1 upon 2.303, it is a new constant is equal to a new constant K1 into B. This indicates that absorbance is directly proportional to thickness of the medium. When thickness is increases, absorbance is increases, because when thickness is increases, the number of absorbing spaces in the path of radiation is more. Therefore, absorbance is more. And when thickness is less, the number of absorbing spaces in the path of medium is less. Therefore, absorbance is less. Therefore, you can say that Lambert's law relate the absorbance with thickness of the medium. Now, second law is called Beer's law. This law can be stated when a beam of monochromatic light, that means single wavelength of light, is allowed to pass through a transparent medium, the rate of decrease of radiant power with the concentration of medium is directly proportional to radiant power of incident light. Mathematically, it can be stated as minus dC minus dP upon dC is directly proportional to P, और proportionality constant हटाएंगे तो ये equation हो जाएगी minus dP upon C is equal to K2P, where dP is the change in radiant power when light of radiant power P passes through an infinitesimally small concentration of sample. dC and K are the proportionality constant, and minus sign indicate that radiant power decreases as concentration path increases. Rearranging the previous equation, you becomes this equation can be rearranging. This equation can be rearranging. We got minus dP upon P is equal to K2 into dC. Integrating this equation between proper limit, suppose that left hand side is integrated between the limit P0 to P and right hand side integrated between the limit 0 to C. This equation becomes minus ln P upon P0 is equal to K2C. So this equation can be left hand side, this equation can be inverted, and it becomes ln P0 upon P is equal to K2C. ln to the base E is converted into log to the base 10 by multiplying it with 2.303. So it becomes 2.303 log to the base 10 P0 upon P is equal to K1 into C. In the same way, rearranging this equation, it becomes log to the base 10 P0 upon P is equal to K1 2.303 into C. But log to the base 10 P0 upon P is the absorbance. This is equal to absorbance. So, this equation becomes this equation becomes absorbance is equal to K2 into C. It indicates that the absorbance is directly proportional to concentration. If concentration is less, you can say that absorbing species in the solution is less. Therefore, absorbance is less. If the concentration is more, means that number of absorbing species in the solution is more. Therefore, absorbance is more. Combined law is called as Lambert's-Beer's law. This law is the combination of two laws, Lambert's law and Beer's law. The law deals with the relationship between radiant power of incident light and transmitted light as a function of thickness of medium as well as concentration of absorbing species. The combined law is also referred simply as Beer's law. Mathematically, law may be derived as see here, the absorbance is equal to constant into thickness of medium into concentration. That means absorbance is directly proportional to thickness of the medium and concentration of the medium. So you can write it as absorbance is equal to constant into B into C. When the concentration is expressed when the concentration is expressed in gram per liter and thickness in centimeter, the constant in the equation is called as absorptivity and can be represented as is capital A absorbance is equal to A small a is called absorptivity and C is B is the path length and C is the concentration. When the concentration is expressed in mole per liter and thickness in centimeter, the constant in this equation, that means E is called as molar absorptivity and it is represented by epsilon. So this equation becomes A is equal to epsilon BC. Thank you for watching.